Hey everyone, we're going to be doing the continuation of the hydrosphere. Now, particular, we're going to be in groundwater. So, precipitation. We know what precipitation is, right? Rain, hail, sleet, or snow. Well, groundwater is what we're going to be learning about today. So, if we have little precipitation becomes runoff. Remember, runoff is when it falls off and goes into a body of water or creates a body of water and is returned into the ocean. The rain infiltrates the ground and becomes groundwater. Porosity is a percentage of the pore space in the materials. So as you see here, this is well sorted sediment, so high porosity. Look at the gaps. They're about even. Poorly sorted, they're all different sizes, low porosity. So we don't have a lot of pores because it's just not organized. Groundwater movement. Now, groundwater moves by twisting and turning through interconnected small openings. The groundwater moves more slowly when the pores are smaller. So, slow when it's smaller. Groundwater movement. Groundwater flows downhill in the direction of a water table. Downhill. Permeability is the ability of a material to let water pass through it. High permeability is large connected pores, so sand or gravel. Low is tiny pores, which is going to be like silt, clay, or shell. So here's the groundwater movement. As you see, look how it flows through clay, silt, but we have a lot moving through this gravel and sand. So the groundwater. Area above the water table. Okay, here's the line. The area above the water table is known as the zone of aeration. Okay, that is here. And it's filled, the pores are filled with air. Now, what I want you to do is draw this table over here in your notebook. All right, so the water table is the upper boundary of the zone of saturation. As you see here, the zone of saturation is the depth below the Earth's surface at which groundwater is completely fills all the pores. This is our groundwater. So the groundwater. The topography of the water table follows the topography of the land above it. So as I told you, zone of aeration, then a water table, then a zone of saturation. Which one is mostly groundwater? Saturation. Because its dependency on precipitation, the water table fluctuates with seasonal and other weather conditions. So some seasons we have it more rainy, some seasons it's more drier. So this does fluctuate deal with the seasons and how much rain that we do get. So aquifers. They are underwater permeable layers where most of the groundwater flow takes place. Okay, so we have the different levels, but you see the aquifer here is right under the impermeable layers, which are called aqueducts, and they are barriers for the groundwater flow. Okay, it kind of helps separate the water from the dirt. I don't think you want to be drinking water that has a lot of dirt or sand in it. So the groundwater, the water table aquifers are unconfined and unprotected and thus easily polluted. Because remember where they are located at. Deep aquifers are called confined aquifers, right here. And they're sandwiched between the aqueducts. So remember the impermeable material, which is here. It says aqueducts are barriers that prevent pollutants from reaching the aquifers, which is correct. As you see here, this right here is called an artesian well, and we have a shallow well. So the shallow well is going to be, again, unconfined, but the artesian well is a confined aquifer, and that's going to give you the clearest and the best water. So confined versus unconfined. So land surface, we have some here. So unconfined, we don't have a barrier. Okay? There's no barrier, so it's right here under the dirt. Well, confined, it has a level that is the aquitort. Remember those imperial layer kind of protects that, so it's like a big rocky layer that protects it from getting all the dirt and stuff in it. So we do have aquifers in North Carolina. Aquifer typical of the Piedmont and mountains. This is pretty much what it would look like. This is the coastal plain. Now for us, you can say we're more between the Piedmont and coastal plains, but if you see us on the chart, you'll find out where we are. So we have a water table here. We have the unconfined aquifer, which is a saturated. Again, it's good water. Bedrock is here, but once we get through a layer, we actually have confined aquifer, but there's sand here. Confined, and there's limestone. Okay, unconfined, and then this calamari. So we do have, of course, when you're near the coastal plain, you're near the ocean. So you're going to find more sand, you're going to find more limestone, you're going to find more pebbles in there versus where we're mostly at is in the Piedmont area, Sand Hills area. And we don't have all those dirt layers. We just have unsaturated and saturated soil. So wells. What is really a well? Well, a well is a hole that is dug or drilled deep in the ground to reach a reservoir of groundwater. So the whole idea is to get a well. That was unsuccessful because obviously it doesn't hit any water. The successful one is that once we drill a hole, the well will tap into an aquifer and water will begin to flow. So here are some key terms for wells. We have a drawdown, which is the difference between the original water table and the water level that's pumped back into the well. We have recharge. It's the process in which water from precipitation and runoff is added back to the zone of saturation. So recharge is added back. So if you're recharging something, you're giving it back. Like if you recharge your battery, you're giving it back your battery some strength. So you're giving this back to the zone of saturation. Over pumping is when it produces a cone of depression around the cell. If you overdo something, um, or you're overwhelmed, you can feel like depressed. So depression, overly doing something. So here is some more information about wells. This is how we talk about the formation of a cone of depression in the water table. So if we have our well set, and these we got great. These are the former water table was here. Before you start pumping, heavy pumping, like a lot of pumping, you can actually make it be overwhelmed. So it decreases. So now our main well has lost, and then our water table has lowered. So now if you look here, your wells are now getting some dirt in it. So if you overly do it, it has a strain to it. Now there are some threats to our water supply. Well, humans depend obviously for fresh water. We need it for household use. We need it for agriculture. We need it for industry. People can actually overuse the water supply system. Well, put it like this. As more as humans we get on this earth, we're going to need more water, right? Because you cannot live without water. Your body can only go a few days without water before it decides to almost kill itself. If groundwater is pumped out at a rate greater than the recharge rate, So if it's pumped out greater than the recharge rate, the groundwater supply will inevitably decrease and the water table will drop, which we call it to be depressed. So another threat, subsidence. So this happens, of course, due to overpumping and a depressed water table. Sinking of the land, but it happens here too, right? Look at the land. The land used to be straight, the ground went down, so did the water, caused by excessive withdrawal of groundwater. If you look here at the ground, you see how that ground is going down? Well, that's the same thing that happened in 1926. Saltwater intrusion. Now, I know if you've been to the beach and you got salt water in your mouth and stuff, you did not like that. So the overpumping of wells near the ocean can cause underlying salt water to rise into the wells and contaminate the freshwater aquifer. So before pumping, you see the water table was good, freshwater level was good, and at the bottom of the groundwater there's salt water. But now we put a pump in here. So the pump, once we over pump it, we get the fresh water begins to get, and depress, and the salt water now becomes our source. We also can have septic waste contamination. Now, everyone has a septic tank at their house. A septic tank is where you use a bathroom at, and there's a big old cube under your house that catches all your poop and pee. Throw up and everything else you flush down the toilet. So now when people are like, oh, it goes down the toilet, it goes there. No, that's where it goes, right there. And so what happens is eventually it does you have to get this flushed out every 5 years. So it won't overflow, especially if you use the bathroom a lot and you got a lot of people in your house. But if it's not done right, everybody has well that has the water. That's why we have like city water. There's a pipe that gets the water under the yard and under the house and in the ground. But if your septic tank is overfull or it's faulty, it's going to pollute all the water. So now you're going to be drinking boo-boo water. So groundwater pollution sources. All major pollution sources needed to be identified and eliminated. Here is a table. So make sure you write this in your notes. So how about protecting our groundwater? How can we protect it? Well, pollution plumes may be stopped by the building of impermeable underground barriers. Polluted groundwater can be pumped out for chemical treatment. So we can stop it by building impermeable underground barriers, as well as the polluted groundwater can be pumped out.